All right, so let's look at solving systems of linear equations algebraically. We're going to learn or review two methods, solving by elimination and solving by substitution. The top three I'm going to use elimination on, and then the bottom three I'm going to use substitution on. So let's take a look at the top equation up there. We've got negative 7x minus 6y equals negative 1, and then we've got 14x plus 5y equals 9. Okay, so figure out what variable it would be easiest to eliminate by multiplying one of those equations by a constant. Okay, well, in the top equation, if I look at my x terms, I've got negative 7x in the top and I've got 14x in the bottom. So if I multiplied the top by 2, that would make that top one negative 14x. But remember, you'd have to multiply every term in that equation by the same number, so then you get minus 12y equals negative 2. I mean, granted, you could multiply the top equation by 5 and the bottom equation by 6 to get rid of your y's, but it would be a lot easier just to get rid of the x's first. So let's multiply the top equation by 2. That's going to make that negative 14x minus 12y equals negative 2. All right? So whenever I combine my new equations, negative 14x plus 14x, the x's cancel out. Negative 12y plus 5y gives me negative 7y. And that's going to equal negative 2 plus 9 equals 7. So if I divide both sides by negative 7, I'm going to get y equals negative 1. Okay? Now that you've solved for y, you can plug back in and solve for x into either one of those equations, okay? Any of those, all right? So I can say 14x plus 5 times negative 1, because that's what y equals 9. So 14x minus 5 equals 9. If I add 5 to both sides, you get 14x equals 14. Therefore, x has to be 1. So your solution would be 1 for x, negative 1 for y. And that's how you would write your solution. Okay? There we go. Zoom on that a little bit. All right, so the next one. Let's see what would be easy to eliminate here. So on the next one, it looks like the y's would be easy to eliminate, because if I multiply the bottom one by 2, that would become negative 8. Positive 8 and negative 8 cancels out, so your y's would cancel out. Okay? Again, you could multiply the top one by 3 and the bottom one by 5, and you could get your x's to cancel out, but it's a lot easier just to get rid of the y's. So let's multiply this by 2. That gives me 6x minus 8y equals 30. Okay? So negative 5x plus 6x is going to give me just x. 8y minus 8y cancels out. That's going to equal 30 minus 21 is 9. So x is 9. Now that I know what x is, I can plug back in and solve for y. Okay, I could say 3 times 9 minus 4y equals 15. So 27 minus 4y equals 15. Subtract 27 from both sides. So you get negative 4y equals negative 12. And then when you divide both sides by negative 4, you're going to get y equals 3. Okay? So your solution would be 9, 3. There you go. And let's look at that last one, solving it by elimination. I've got negative 2x plus y equals 0, and 10x plus 7y equals 48. Well, again, either one would really be easy, but if I multiply the top equation by 5, that would make that negative 10x plus 5y equals 0, okay? And then my x's are going to cancel out. Negative 10x plus 10x cancels out. 5y plus 7y is 12y. And then 0 plus 48 is 48. Therefore, y would have to be 4, okay? 48 divided by 12 is 4. And then to solve for x, I can just say 10x plus 7 times 4 equals 48. So 10x plus 28 equals 48. So subtract 28 from both sides, and you're going to get 10x equals 20. So x has to be 2. All right? So your solution is 2, 4. There you go. All right, so that's solving by elimination.